Lesson 2.8, Literal Equations and Dimensional Analysis. The objective today is to solve equations for a given variable. You're going to use formulas to solve real-world problems also. The algebra standard is 2.2. And basically we're going to just focus on the first part, literal equations today. And you take an equation in which there's lots more variables than just one. And you're going to solve for one variable in particular, meaning that you isolate that, get that variable by itself, and everything else to the other side. So this tells us who really knows the process of solving equations. When you can do this, you really know the steps of solving an equation. It's not one of those things where, well, you know what the answer is, so you can figure it out and then maybe write some stuff down to get there. This really shows who knows the steps. All right, so let's go to our first example, example A. They're going to give you the problem, and then they're going to say at the end for the variable they want you to solve for. Okay? So example A says ax minus b equals c. And our job is to solve this one for x. Well, thank heavens for now there is only one x term, and it's ax. I'm going to deal with that last. I got to take the minus b to the other side. So to take minus something to the other side, you would show plus b. And you do that to each side. Draw your line, just like we did when we solved equations before, and bring down below the line what you have. So I have ax, the minus b plus b cancels out. I bring down the equal sign, and I'm going to try to do this in alphabetical order as best I can. So I would put b plus c. And now I need to go one more step, getting x by itself. It's a times x, so we know that you undo times with division. So we divide on both sides by a. And on the left, a divided by a cancels, x equals, and it's literally what you see there, b plus c all over a. That is your final answer. When you get the variable that they want you to solve for all alone, then you're done. Questions? Yeah?
Can I do the next one?
Well, we can try. 7x plus 3y equals m, and your job is to get 3y by itself. Or I'm sorry, to get y by itself. So what do you think I'm going to do first?
You're going to add 7 or
Subtract
subtract 7x.
7x.
Then you bring down 3y equals m minus 7x.
Okay.
Divide that by 3. And then y equals m minus 7x over 3.
Yep. Y equals m minus 7x over 3. Okay, now look at C. It says Q minus R equals R, and we're solving for R. So Jared, what do you think?
You add r to the other side.
Yeah, you got to bring the R's together somehow.
So it'll be q equals 2r.
Q equals 2R.
And divide each side by 2.
Divide each side by 2.
And then it'll be r equals q over 2.
R equals Q over 2. Yes?
I'm just curious, why would you do the q first?
Because there is an R on both sides, and when there's an R on both sides, you've got to bring those together before you do anything else. Okay, that's the way that one's going to be. All right, so questions on those three? Anybody still writing those three? Okay,
Okay.
let's move on. So example D, A equals H times the quantity A plus B over 2. And we're solving for H. So this one, I think I'm going to show you so that there's only one H, so that's good. Okay, there's only one H, so that's good. I've got to try to get rid of, first of all, the 2. So that would make me multiply by 2 on both sides. So 2A equals, and that 2 cancels with that 2. So H over A plus B. Now, a lot of times when there's parentheses and something outside, you do distribute. But in this case, that would be a big mistake because we want to isolate H, and the only thing that's keeping H from being by itself is that quantity A plus B. H is times that. So basically what you do is you have to divide A plus B. So that's gone and H is alone, and the left side would be 2A over A plus B. There you go. All right, example E. DF plus 10 all over 6 equals G. So we need to get F alone. Okay, Ethan, are you doing it?
Yeah.
All right, what should we do first?
You times the bottom 6 by 6.
Okay, everything by 6, both sides by 6.
Yes.
Okay, so that's going to take care of these 2 6s. Now what?
Then you subtract 10.
Well, what do I bring down?
Oh, you bring down DF plus 10
Equals
6G.
6G. Okay, and now
You subtract by 10.
subtract both sides by 10. Draw my line. What do I bring down?
DF equals 6G minus 10.
Okay. And
Then you divide by D.
divide by D. So F equals
6G minus 10 over D.
There you go. Very good. You guys are doing really well with this. What do you think? Okay. All right. Anybody still writing the red? Because we need to move on a little bit further. Okay. So, again, you're trying to isolate the variable they ask you about. Now, here's the problem. This time, it says you may have to use reverse distributive property. It's really distributive property, but I'm going to call it reverse because most of the time when I talk about distributive property, kids think of taking something outside a parenthesis and multiplying it through, distributing it. Well, this is the opposite of that, is what you're going to have to do with these. Okay, so this example says AX plus Z equals AW minus Y, and we have to solve it for A. So that's a problem. A is in 2 different things. So I've got to somehow bring my A's together. So what I'm going to do, because of alphabetical, well, not really alphabetical order, but what I'm going to do is I'm going to bring my AW to the other side. So I'm going to subtract AW from both sides. And that will give me AX minus AW plus Z, and that would equal negative y. Okay, next, I've got my two a terms on the left, but that z is kind of in the way, so I'm going to bring that over. I don't need to mess with that right now, so I'm going to subtract z. So I have ax minus aw equals negative y minus z. Okay, here's where the reverse distributive comes in. You see how the a is in both of those? There's no way that I can isolate them when they're in two different things. So what I'm going to do is I'm going to bring the a out in front, and it's really called factoring, okay? But we're going to refer to it reverse distributive. You might understand a little bit better. Either way, I am taking the a out of both of those terms. So if I take a out of ax, I just have x. And if I have a out of aw, make sure you bring the minus down, I have w. That equals negative y minus z. So now it looks a little bit better, right? It's a times something. Well, to get rid of that times something, I'm going to divide both sides by x minus w, and that cancels. So my a equals negative y minus z over x minus w. Okay, questions?